Hello everyone, this is Dr. Lennon. Today we're going to be going over the Test 1 review. So the topics include solving inequalities, linear equations, quadratic equations, and systems of equations. So the first one we're looking at is an inequality problem. So the first thing we want to do is get the x's on one side. So we'll start by adding x to move all the x's to the left-hand side. So now we have 6x minus 10 is less than 8. Then we want to move the regular numbers to the other side, and we accomplish that by adding 10. So we have 6x is less than 18. And then we divide by 6, and we have x is less than 3. So graphically, these are all the numbers that are less than 3. So we would do an open dot and then shade in this direction. And in interval notation, that would correspond to negative infinity up to 3 with an open grouping symbol. Remember, we use a square bracket if we're going to include the number, which would happen if it would be less than or equal to. But in this case, it's just strictly less than. For number 2, we have something similar. We have a compound inequality because it has 3 parts. And I've used this symbol, so really we can think about this as negative 3 less than 4 minus 3x. And then less than or equal, I don't have that ability to type that, so that stands for less than or equal to 10. So what we want to do here is we want to leave the x component in the middle and move the numbers to the outside. So we can do that by subtracting 4 from all 3 parts. So for these compound inequalities, whatever you do to one part, you have to do to all 3 parts. So we have negative 7 less than negative 3x less than or equal to 6. And then we need to divide by negative 3 to isolate x. And remember, whenever you divide by a negative, you need to flip the direction of the inequality symbols. So we'll divide all 3 parts by negative 3, but in the next line we're going to have to flip these symbols. So we'll have 7 over 3 is greater than x, which is greater than or equal to negative 2. So when we graph that, or we scrolled a little too far. So graphically, this would just correspond to those numbers. The larger of the two numbers is 7 over 3, and the smaller is negative 2. We're including negative 2, so it's shaded, and 7 over 3 is an open dot. And in our interval notation, this would be negative 2 with a square symbol, since we're including it up to 7 over 3, which is just like a boundary point. Okay, so this next one we want to solve and graph the inequality. This one is a quadratic inequality. So we accomplish that by factoring. So this one factors pretty easily as x minus 4 times x plus 3 greater than 0. And remember, we solve this by setting up test value regions. So what does that mean? Well, we have the two numbers that would make the left-hand side 0, which are negative 3 and positive 4. And that will divide this into 3 distinct regions. And we want to test a number in each one of those regions to see if it's positive or negative in that region. And since our inequality is asking if it's bigger than 0, then it will be part of the solution if it comes out as a positive. So in region 1, you could plug in, say, negative 4, and you would end up with negative 4 minus 4, which is negative 8. Times negative 1, which would be positive 8, so it comes out positive in region 1. Region 2, we could plug in 0. We would end up with negative 4 times negative 3, or negative 4 times positive 3, which is negative 12, which is not greater than 0. So that's negative. So this is part of the solution, this is not. And then in region 3, we could, say, plug in 5, and we would get 1 times 8, which comes out to a positive as well. So the regions that are part of our solution are regions 1 and 3. So graphically, this would look like, and it's greater than 0, so both will be open dots. We'd have our negative 3, our 4. We would shade in this direction, and then we would also shade in this direction. And so our interval notation, we just do each part individually, negative infinity up to negative 3, and 4 up to positive infinity. And then to join two distinct regions, we put that U for union in the middle. So that would be our interval notation for number 3 there. Okay, moving on to systems of equations. So usually these are representing two lines, and we're looking to, my favorite method is the elimination method, where we just try to multiply equations so that we eliminate one of the variables. So that can be accomplished if you look at the x's. If we multiply the top equation by 2, we'll end up with 6x, and we know if you add them, 6x and minus 6x will add up to 0. So what I'm going to do is I'm going to multiply the top equation by 2, and the bottom equation I'm going to keep the same. And remember, you have to multiply every individual term in that top equation from the distributive law. So you would end up with 6x minus 4y equals minus 26. And on the bottom, we would have just the same thing, minus 6x plus 5y equals 28. And then we could go ahead and add them together. So this 6x and the minus 6x cancel. Negative 4y plus 5y is just the 1y. And negative 26 plus 28 is 2. And then you want to plug that into one of the original equations. So let's just say the top one, 3x minus 2 times 2. This would equal negative 13. So we have 3x minus 4 equals negative 13. And then we could add 4. So we have 3x equals negative 9. And when we divide by 3, we get x equals minus 3. So the solution here is the ordered pair, negative 3, 2. So that is the answer there. Number 5 is also a system of equation problem, but it's coming from a word problem. So in this problem, we have a coffee shop, and they want to blend 2 different types of coffee. So what we're going to end up with is a volume equation and also a cost equation. So let's let K be the, let's say, pounds of Kenyan mixed. And we'll let, I'm going to use L because my S can look like a 5. This is the pounds of Sri Lankan. Okay, so from that we should be able to get our 2 equations that will give us something to solve. So we know that we're buying a total of 3 pounds. So the blend is 3 total pounds. So K plus L would equal 3. And we know the cost is $14.75. So the cost equation, you have to multiply the cost per pound times the number of pounds used. So for Kenyan, it would be 4.5 times the K. And then for the Sri Lankan, it was 560. So that's plus 5.6 times the L. And that should equal the total cost of $14.75. And then there's a number of ways you can do this. I don't know. Let's try elimination again. So I could multiply this one, let's say, times negative 9. And then multiply the bottom equation by 2. That way I'll have negative 9k on top and 9k on bottom. So I'll have negative 9k minus 9l equals negative 27. And my bottom equation will be 9k plus 11.2l. And that will equal 2950. So then we can add them together. So the negative 9k and the positive 9k cancel. And negative 9l plus 11.2 is 2.2l. And negative 27 plus 29.5 comes out to 2.5. So then to solve for L, we just divide by 2.2. So this comes out to not a very exact number. It comes out to about L equals, if I round to 2 decimal places, 1.14 pounds. And then again, we could plug that back into this original equation. So let's say K plus 1.14 equals 3. And then we subtract that number. So K is about, let's say 1.86. So the conclusion there is the blend contains 1.86 pounds Kenyan 1.14 pounds Sri Lankan. Okay, so now we move on to quadratic equations. So again, we already kind of saw one from the inequality section, but just to reiterate, when you have this easy case, x squared plus 21x plus 24, you just have to look at the last number, 24, and you need two numbers that multiply to 24 but add up to the middle number. So that's going to be 8 and 3. So x plus 3 times, oh, I think that's a typo. I think I meant to write 11 there. So yeah, that's my mistake. Let me see if I can fix that. Yes, I've fixed that now. If we would have had it as 21x, I don't believe it would have factored. So x plus 3 and x plus 8 is what I wanted here. So then you just set each separate linear factor to 0 and solve. So we get x equals -3 or x equals -8. So that was the goal here. So we needed to find two numbers that multiplied to 24 and added to 11. So you're going to have to do the same thing in the next problem, but it's not the easiest case. So this is the harder case because we have a number in front. So the first thing we have to do here is we have to multiply the first number 5 times the last number 8. So the leading coefficient with a constant, so we end up with 5 times 8 is 40. And we need numbers that multiply to 40 but add to -44. So that's going to be -4 and -10, right? So that's how we're going to split the middle term. -4x minus 10x equals -14x. And again, I've messed up the middle term for the practice problem. I apologize. This is meant to be -14x, not -44. So that's my mistake again. Sorry about that. So we need two numbers. That's how we found these. That multiply to 40, but add to -14. And then this is where we employ the grouping process. So we rewrite the same equation 5x squared, but now instead of -14x, we use -4x minus 10x plus 8 equals 0. And we factor the GCF from each group. So the 5x squared minus 4x, that's all we can take out as an x. And we're left with 5x minus 4. And then from the second group, we can take out a -2. And then we're also left with 5x minus 4. And then the 5x minus 4 is a common binomial factor, so we get the x minus 2 times the 5x minus 4. And then we have either x minus 2 equals 0 or 5x minus 4 equals 0. And then solving those, you get your two answers, x equals 2 or x equals 4/5. And those are the two solutions for this problem. All right, so the problem number 8, we need to use the quadratic formula. So remember, the quadratic formula looks like x equals -b plus or minus the square root of b squared minus 4ac divided by 2 times a. And so for this problem, we have our a, b, and c are the numbers in front of x squared, x, and the constant term respectively. So we have a equals 1, b equals -11, and c is equal to 1. So we take those numbers and we just plug it into the formula and simplify. So that's how we get our answer. X is, so -b would now be +11 since b is already negative. So we get 11 plus or minus the square root of b squared, which is negative 11 in parentheses squared, minus 4 times 1 times 1, with everything being divided by 2 times 1. And then we simplify. So x is 11 plus or minus the square root of 121 minus 4 over 2. And then this is the end right here. 11 plus or minus the square root of 117 over 2. And that is that. Those are the two answers using the quadratic formula. So not a lot of thought in terms of algebra. You just need to make sure that you're plugging things into the formula correctly and using parentheses. I would say the most common mistake here is the b squared part. If b happens to be negative, if you forget to put the parentheses around that negative 11, you could end up with negative 121 rather than positive 121. Okay, the last two problems are linear equation problems. So find the equation of the line that passes through 5, 7 and negative 1, 15. So we start with the slope. M is going to be 15 minus 7 divided by negative 1 minus 5, which comes out to 8 over negative 6, which simplifies to negative 4/3. Remember that this is just y2 minus y1 over x2 minus x1 to find the slope. So now we know that the equation of our line looks like y equals negative 4 over 3x plus b, and we just can plug in either one of those 2 points to find b. So let's go ahead and plug in 5, 7. So 7 replaces y, and 5 replaces x, and we're just trying to solve for b. So we end up with 7 equals negative 20 over 3 plus b. So let's go ahead and continue up here. So let's make 7 have a common denominator. So 7 times 3 over 3 is 7 is the same thing as 21 over 3. That's negative 20 over 3 plus b. And then we want to add 20 over 3 to both sides. So in doing so, we end up with 41 over 3 since we have the common denominator. And that's the value of b. So we end up with y equals our slope, negative 4 over 3x, plus our y-intercept, 41 over 3. And that is using slope-intercept form as our answer, y equals mx plus b. Okay, the last one is finding the equation of a line. And we're given a point that it passes through and also a perpendicular line. So y equals negative x over 3 can also be thought of y equals negative 1/3 x plus 7. So the first thing, the slope of our line. So the slope of our line is the opposite reciprocal of negative 1 over 3. So that means we flip it over and change the slot and change the sign. So our slope should be 3. Okay, now we can just do the same trick that we did last problem. We have y equals 3x plus the y-intercept. And we can plug in the point negative 5, 2 to figure out the value of b. So let's let 2 replace y and negative 5 replace x. And we end up with 2 is equal to negative 15 plus b. And that's all we have to do is go ahead and add 15 to both sides. So once we've accomplished that, then we have found the equation of our line in slope-intercept form. So we have 17 is equal to b. So our line is y equals 3x plus 17. So that is the equation of our line, and that is it for the test review. So again, the topics on the test include inequalities, linear and quadratic, and then we also have solving quadratic equations, solving systems of equations, and then looking at equations and graphs of linear functions. So that's it for the test review, and this is Dr. Lennon signing off.